Rules for determining the functional dependency. There are two things. One is Armstrong's axiom and closure of attributes. We'll discuss only about the Armstrong axioms. As we have seen earlier, functional dependency is very crucial concept in database management system. It helps in maintaining the data integrity and understanding it better. And this Armstrong's axiom, these are set of rules that plays a fundamental role in defining and simplifying the functional dependency within the relational database. And what is the benefit of understanding the functional dependency is to help to identify the redundant data, simplifies the schema design and improves the data consistency. Now, Armstrong axioms is here you have a set of rules used to derive all the functional dependencies that hold in a given database relationship. There are three axioms. One is axiom of reflexivity, augmentation, axioms of augmentation, and axioms of transitivity. First, when coming to reflexivity, if A is a set of attributes in a relation R, then A tends to A holds true. This means every attribute set is functionally dependent on itself. For this, we can take an example of student ID. That in the student database, if we have an attribute student ID, it is trivially true that student ID determines a student ID, as we have discussed in trivial functional dependency. Second point is augmentation. Here this axiom of augmentation tells us that if a functional dependency existed between two set of attributes, if we are adding more attributes to both the sides of dependency, it does not change the dependency. For example, here they have given in terms of A and B. A tends to B is a functional dependency in a relation R. Then for any set of attributes C, then AC belongs to BC holds true. This means if we determine the B from A, we can also determine B from any superset of A. For example, if a student ID determines the student name, then it also implies student ID, course code determines the student name and course code. Coming to the next one, axiom of transitivity. This states if we have two dependency, when one attribute set determines another and the second set determines the third set, then we can infer that first set determines the third set. For example, if student ID determines the course code and the course code determines the course name, then the student ID determines the course name. That is what A tends to B and B tends to C. It holds true that A tends to C. That is what the student ID determines the course code and course code determines the course name. So directly it represents student ID determines the course name. Here, using these axioms, we can derive all other functional dependency that holds in a given relationship. For example, given a functional dependency A tends to B and B tends to C, we can use the transitivity axiom to derive the functional dependency A tends to C. This process is called closure computation and it is an essential step in database normalization. Now, here again, axioms or the rule of inference provide a simpler technique for reasoning about the functional dependency. In the rules that follow, we use the Greek letters alpha, beta, gamma for set of attributes and upper Roman letters from the beginning of the alphabet for individual attributes. We use alpha, beta to denote alpha union beta. We can use these three rules to logically imply functional dependency. By using these rules repeatedly, we can be able to find the functional dependency if these are the collection of rules. Then here again the same thing in terms of Roman letters, alpha 10. Alpha is the set of attributes and beta is a subset of alpha. Then alpha tends to beta holds. Similarly for augmentation rule, if alpha tends to beta holds, gamma is a set of attributes, then gamma of alpha tends to gamma beta, it holds true. Then similarly transitivity, here Armstrong axioms are sound. They don't generate any incorrect functional dependency. They are complete because for a given set of functional dependency, they allows us to generate F plus. That is, it is a representation. Here, apart from that, additional rules, or we can say it as secondary rules like union rule. If A determines B and A determines C, then we can derive A determines BC. In terms of alpha beta, it is being represented. I am saying in terms of AB. Similarly, decomposition rule here, it decomposes a dependency into two or more dependency. For example, A and B, A comma B determines C. Then D, if we decompose it into A determines C and B determines D. Coming to pseudo-transitivity, it is an extension of transitivity axiom, allowing us to infer new dependency based on the existing ones. Suppose if A determines B, C and C determines D, we can use the pseudo-transitivity to infer A determines BD. Thank you.